There is a tree growing along riverbanks across the northern hemisphere that most people assume is a useless riverside scrub. On a daily basis, many of us walk past it in our parks or clear it from our drainage ditches, completely oblivious to the true power this plant possesses and the vital role it plays in modern medicine. This humble species contains a chemical intelligence so sophisticated that it has managed to solve the three greatest puzzles of human health: pain, fever, and inflammation. This tree is so remarkable that it produces a molecular template that is considered by many to be a technical impossibility. It is a biological anomaly that can literally stop a heart attack in its tracks, shield the human colon from the mutations of cancer, and switch off the neurological pathways of agony with the precision of a master surgeon. Today, we consume over 100 billion doses of its synthetic replica every single year. This single plant has allowed for the creation of the most successful drug in human history, a medical miracle that forms the foundation of the modern pharmaceutical cabinet and generates billions in revenue for the companies that now own it. And the most amazing part of this story? This tree is so common that it is likely within walking distance of your front door. This is the story of the willow tree and how it gave us the most successful drug in the modern world, aspirin. To understand the origin of this wonder tree, we have to travel back before the first pharmacy, before the first hospital, to the very cradle of civilization. In 3000 BC, the Sumerians, the architects of the first cities, recorded a specific treatment for the heat in the limbs, a common pain we now know as inflammation. Their remedy was a simple but effective one. They covered the inflamed areas with leaves of the willow tree. They didn't understand the chemistry behind the plant, they simply saw that it worked. By 1550 BC, the Egyptians codified this in the Ebers Papyrus, one of the oldest medical texts in existence. They called the tree Gerrit, and again, they used its bark to draw the heat out of wounds. Across the Mediterranean, Hippocrates, the father of modern medicine, prescribed a bitter powder extracted from willow bark to ease the excruciating pains of childbirth and to break fevers. At the same time, halfway across the globe, Chinese physicians were independently using willow shoots and poplar bark to treat rheumatic fever and hemorrhages. Even in the Americas, the Cherokee and the Haudenosaunee utilized the inner bark of the willow for headaches and muscle aches long before a single European ship ever touched their shores. For 4,000 years, the willow was a medical marvel recognized time and time again by civilizations across the planet. It was the people's pharmacy, a free, abundant resource that existed wherever there was water. So, how did willow, a tree highly coveted by all of the greatest civilizations in human history, become to be perceived as a useless swamp shrub? Well, the reason was due to a shift that occurred in the mid-18th century. In 1763, an English vicar named Edward Stone rediscovered the bark's power during a malarial outbreak. Stone noticed the extreme bitterness of willow bark. In an era where bitterness was linked to medicinal potency, he conducted a methodical 5-year experiment, drying and powdering the bark to cure the agues or malarial fevers. He reported his success to the Royal Society, providing the first modern scientific validation of what the Sumerians already knew. But as the 19th century dawned, the focus shifted. Science no longer wanted the tree, it wanted the molecule. In 1828, at Munich University, Joseph Buchner succeeded in extracting yellow crystals from the bark, which he named salicin. The tree was no longer seen as a healer, it was raw material. Once we isolated the crystalline form, the willow was slowly pushed out of the medicine cabinet and into the industrial factory. And by the time we reached the mid-1800s, the tree was considered obsolete, replaced by a concentrated acid that was about to be rebranded and sold to the masses. But to understand why the willow is the ultimate wonder drug, we have to look at its impossible biology. Salicylic acid is a vital hormone that serves as the cornerstone of the plant's immune system. When a willow tree is attacked by insects or scorched by a drought, it undergoes a metabolic response. It uses the phenylalanine ammonia lyase pathway to synthesize salicylic acid. This acid acts as a biological alarm system, triggering stomatal closure to conserve water and regulating proteins that create a chemical shield against fungal pathogens. It uses these compounds to regulate abiotic stress. It triggers stomatal closure to conserve water during droughts and regulates proteins that act like a chemical shield against fungal pathogens. It is a biological signaling system that has allowed the Salix genus to survive for millions of years. But for humans, the willow bark contains something far more complex than a standard painkiller. When you use the willow bark as medicine, you are consuming a symphony of natural compounds. The bark contains flavonoids, polyphenols, and tannins that act as natural buffers, protecting the stomach lining while delivering the medicine. But this all raises an important question. If the willow tree is this powerful, why are we buying it in plastic bottles? In its original synthesized form, salicylic acid was effective but violent. It was incredibly bitter and highly caustic. It literally burned the stomachs of patients, causing internal bleeding. But in 1897, a chemist at Bayer named Felix Hoffmann was desperate to help his father, who suffered from crippling rheumatism but couldn't stomach the acid. Hoffmann added an acetyl group to the molecule, creating acetyl salicylic acid. This stabilized it and made the liquid more palatable. More importantly, this formula was now both patentable and a commercial commodity. In 1899, Bayer registered the name Aspirin. The A stood for acetyl. The spear came from Spirea ulmaria, the meadowsweet plant, another natural source of salicin. This is where the commercial takeover began. Once the name was trademarked and the process was industrialized, the willow tree was rebranded as Primitive. The pharmaceutical industry transformed a free, wild, medical resource into a $40 billion annual commodity. Like any natural herbal remedy, you cannot patent a white willow tree. And you cannot charge $20 a bottle for something that grows for free in every corner of the planet. So, the commercial system incentivizes the synthetic over the botanical. Now we are taught that the pill is the medicine, and the bark is simply the skin of a weed. Today, we produce 40,000 tons of synthetic aspirin annually, while the very wetlands where the original willow plants once grew are now being drained and paved over, essentially destroying the source to sell a product. For over 70 years, people used aspirin, aware of its medicinal powers, but unsure why it was able to relieve pain so effectively. But in 1971, British pharmacologist John Vane discovered the Prostaglandin Breakthrough, a discovery so profound it earned him the Nobel Prize. Vane discovered that aspirin works through a process called irreversible acetylation. Inside all of us, there is a micromolecule called the COX enzyme that produces something called prostaglandins, chemical messengers that tell your brain you are in pain. But aspirin doesn't just mask these messengers. It enters that molecular lock and breaks the key off inside. It permanently disables the enzyme. This is a level of molecular precision that evolution perfected in the bark of a tree long before humans even discovered the wheel. But there is a second, even more miraculous trait hidden in this willow logic, and that's its effect on blood. Platelets, the cells that make your blood clot, do not have a nucleus. This means they cannot regenerate the COX enzyme once it has been disabled. A single dose of aspirin disables a platelet's ability to clot for its entire 10-day lifespan. This biochemical quirk is exactly why a derivative of a common swamp tree has become the world's primary defense against heart attacks and strokes. And even now, we are still discovering new abilities of the willow tree. Recent studies in fruit fly models have shown that this willow derivative can reduce metabolic inflammation and trigger anti-inflammatory lipids that help resolve tissue damage from infections. We are now finding that aspirin use is associated with a significantly reduced risk of colorectal cancer. It appears the willow wasn't just a painkiller, it was a genetic shield. But the willow's story isn't over. As we face the rise of antibiotic resistance and new, complex viral threats, scientists are realizing that entirely synthetic drugs are often too simple for the complex diseases of the 21st century. So, the Earth Biogenome Project is currently racing to sequence the DNA of all 1.6 million known species by 2032. Modern startups are now using machine learning to analyze the metabolic pathways of plants, like the willow. They are finding that the original willow bark contains a library of bioactive metabolites, flavonoids like isoquercitrin and polyphenols, that actually work better than synthetic aspirin because they provide a broad-spectrum effect with fewer side effects. Recent research shows that aspirin, our willow derivative, has chemopreventive powers against colorectal cancer by suppressing the chronic inflammation that drives mutation. We are finding that the original bark, with its complex polyphenols, often has fewer side effects than the synthetic alternatives. And the great thing about the willow as a plant is that it is a survivor. It can thrive in soils contaminated with heavy metals, all while cleaning the earth through a process called phytoremediation. It stores carbon, prevents riverbank erosion, and provides a habitat for thousands of species. It is a tree that can not only heal us, but the planet too. So how do you identify this natural wonder that might already be in your backyard? There are many different types of willow, all suited to different ecosystems and possessing varying properties. The white willow, Salix alba, for example, is a tall, graceful tree often found near water. You can identify it by its unique, lance-shaped leaves with finely serrated edges. And if you flip the leaf over, it has a beautiful, silver-white underside that seems to shimmer or glow when the wind blows. In the early spring, keep an eye out for the purple willow Salix purpurea, which has a much higher concentration of salicin and was often used for intense inflammation. Then there's the meadow sweet Filipendula ulmaria, which grows in damp meadows and produces frothy, cream-coloured flowers that smell like sweet almonds and honey. To use the willow sustainably, you must remember the ancient protocol. Never girdle a tree by stripping the bark from the main trunk. This will kill it. Instead, harvest small, young branches. The medicine is in the inner bark, the green, moist layer just beneath the outer grey skin. The most effective way to preserve this is through slow drying in the shade. Never dry willow in direct sunlight, as the UV rays can degrade the delicate phenolic glycosides. Once the bark is crisp, it can be ground into a powder or steeped into a bitter tea. This tea is the original aspirin, a slow-release, buffered, complex medicine that has been tested by evolution for 3 million years. So what does the story of aspirin teach us about arboriculture and modern society? For starters, it teaches us that scarcity is a manufactured narrative. The willow tree does not require a prescription or ask for your insurance card. It has stood in our gardens, along our fields, and in the silence of our wetlands for millennia, offering a cure for our pain and a shield for our hearts for the price of a little bit of knowledge. But the wonder isn't the drug in the plastic bottle. The wonder is the relationship between the human body and the botanical world, a relationship that has been carefully built through 4,000 years of ethnobotanical history. Every time we lose a species to extinction, we are burning a book in the ultimate library of cures. Protecting the natural world isn't an act of charity, it's an act of self-preservation. The tree that gave us aspirin has saved hundreds of millions of lives. The challenge that we face is that we have been conditioned to believe that advanced solutions must come from a laboratory, and that anything that grows for free in a swamp is worthless. But the willow proves that the most advanced technology on this planet is a bit of bark that's been growing in nature for thousands of years. If you enjoyed this story, then why not check out our recent video on the Pacific yew? We uncovered how the remarkable properties of this tree literally kills cancer and save thousands of lives every year. Thanks for watching!